The moon is one of the most extreme and hostile environments, with no atmosphere, extreme temperatures that can reach a scorching 250 degrees Fahrenheit, or 121 Celsius, to a freezing minus 208 Fahrenheit, or minus 133 Celsius, no oxygen, exposure to radiation and other cosmic threats. During these past weeks, my cohort has been exploring moon and Martian habitats to design settlements, and using artificial intelligence for image generation through meticulous prompt engineering. As you can already guess, I chose Lunar Habitats. As a big dreamer from the Dominican Republic, an island in the Caribbean, I have been deeply curious about design, space, and technology, not necessarily all together. YSP provided fertile ground to explore these as a whole. The main question was, how can we, by looking outwards, reimagine what sustainable futures could look like on Earth? I began my project by going through existing literature on space architecture, the physical, environmental, psychological, and sociological constraints. These elements, along with existing architectural sketches, allowed me to brainstorm some design ideas. However, I wonder what would lunar biomimicry look like? Biomimicry is the practice of making technological and industrial design copy natural processes. Could imagining an insect-like creature millions of years from now guide my design? Could this help inform the future of space architecture? Going back and forth between space architecture reports, scientific literature, and AI prompts, I generated Cryospora luminex, a slow-moving, spiraled arthro-mollusk evolved over tens of millennia alongside human lunar settlements, and this insect-like creature became the baseline for my designs. Combining the Cryospora luminex with fractal patterns emerging from golden ratio and Fibonacci sequence, spatial parameters, and existing visual references, I was able to take what started as a very rough idea into Habitat Cryospora. Following a similar creative and logical sequence, I concretized my prompt to generate a lunar shell crawler, a creature similar to Cryospora luminex, which inspired a lunar power grid control center. Both designs incorporate self-healing autonomous drones, powered by AI and quantum computing, which allow the continuous maintenance and monitoring of the habitat and in-situ resource utilization, ISRU. ISRU is the harnessing of local natural resources at mission destinations instead of taking all needed supplies from Earth, which can be extremely costly, to enhance the capabilities of human exploration. Habitat Cryospora, self-healing autonomous drones use lunar soil, also called regolith, to extract materials using biomining techniques. By incorporating redundancy through concentric circles and fractal-based design, the habitat and settlers' resilience to external threats such as meteorites, radiation storms, and other environmental threats is enhanced. The habitat also incorporates microgrids that use fission, solar, and small-scale fungi-based energy generation. As Earth's regions become more impacted by climate change, maybe thinking on a lunar scale could help us design for sustainable futures. Maybe we could use fungi to remediate highly polluted ecosystems. What about resilient energy grids in hurricane-affected countries? Maybe engineering innovative biomaterials using local resources could help us close the loop on an industrial scale. What about observing small creatures, such as insects, and their intricate evolution on this planet, to use as a reference for how we build things? This is what my project on lunar habitat designs has been all about, allowing curiosity to roam by exploring how futuristic technologies currently researched and developed for space settlements could be applied for an ever-changing planet amidst climate change.